Hi friends, this is Salujan here. Welcome to my networking channel. Hope all are doing good and safe. And today let us discuss about IBGP full mesh neighbor relationship. So by default, IBGP forms a full mesh relationship with each other. That means each and every router will be in a full mesh neighbor relationship with all other routers. So whenever it receives any information from external routes, it will update all the router about the information, right? So that means each and every router is in full mesh neighbor relationship with all other router in an IBGP environment. So always keep it in mind, the updates are not bit sent between the directly connected neighbors. Always the IBGP relationship are formed through neighbors. So that's the thing you have to always keep it in mind. So these two routers R5 and R6 are in an external autonomous system number. So whenever it receives any update, automatically it will update all the information to all other router, because since it is in full mesh with all other router, right? So that is the benefit of IBGP full mesh neighbor relationship. So now let us go to the individual router and I will configure the neighbor relationship and about IBGP full mesh. So let us go to each configuration. So this is a file I have saved R1. So let us configure. So what I have done, so for each and every router R1, right? So for R1, I have configured explicitly configured the neighbors like R2, R3 and R4. I have configured everything as a loopback address, right? So R1 will be having neighbor address 2.2, 3.3, 4.4, and it is in one external neighbor, that is 6.6, right? It is in that is residing in an external autonomous system. So that is the reason here I specify EBGB multi-hop. So since this R1 is peering using the loopback address, so you have to always use EBGB multi-hop. And since we are repairing using the loopback address, we are using update source loopback one. Similar with all the other IBGP neighbors are using update source loopback one. And next stop self is already, whenever EBGB is advertising any neighbor to an IBGP, so we have to change the next stop attribute. So that is the reason I'm using next stop self, right? So now let us go to the other router and we'll configure it. So let us go to R2 and let us configure the BGP neighbor relationship, right? So go to R2. Similarly, I have to configure the BGP neighbor. So it has neighbor like 1.1, 3.3 and 4.4. These all are full mesh IBGP neighbor relationship. So I have to explicitly configure the neighbor for all these three routers, right? So R2 will be in a full mesh with R1, R4 and R3. So these are the loopback address I have specified as a neighbor for R2, right? So we're done with the R2 configuration. Now let us go to R3. Similarly, R3 will be having a neighbor relationship of full mesh, right? R1, R2 and R4, and it has one external neighbor, that is R5. So let us configure. R3 will go ahead and configure. So BGP no synchronization, and neighbor is, it will have neighbor 1.1, 2.2 and 4.4, right? And 5.5 is an external neighbor. Since I'm peering using a loopback address, I have mentioned as EBG multi-hop and update source loopback one, right? So now we'll go to R4 and we'll configure. So R4 similarly it has a full mesh with R1, R2 and R3, right? So R4 has three neighbors. So that neighbors we have to configure it explicitly, right? So let us configure R1, R4, right? So let us R4, go to R4 and let us configure. So I have to configure for R4 also. R4 has three neighbors, right? 1.1, 2.2 and 3.3. And similarly, now we'll configure for the external neighbor. So external nothing but R5 and R6, right? So it has only one EBGP neighbor. We'll go ahead and configure it. So now we'll go configure R5. Go to configuration mode and go to R5 configuration mode, right? So we configured 3.3. It has only one neighbor. There is an EBGP neighbor. That's the reason we are using EBGP multi-hub. And go to similar R6. So R6 has one EBGP neighbor, right? 16.1. So that also will configure R6. So we configure for R6 also. R6 has one EBGP neighbor, that is 1.1.1, right? I am peering with the loopback address. Similar way for peering for IBGP also I use the loopback address. So now let us see whether the IBGP neighbor relationship has been established, right? It is a full mesh neighbor, right? Show IP BGP all summary. See, still it is showing in the active state. So since I'm pairing with the loopback address, either I can use a static route or an internal routing protocol. Since I have done a full mesh IBGP neighbor relationship, so best thing I have to do is I have to advertise via internal routing protocol. So in this scenario, I'm going to use routing protocol OSPF, right? So still you are seeing the neighbor is in active state. That means it has not been established properly. So that is the reason it is showing in a active state. So for getting BGP neighbor established state, what we have to do, we have to advertise via the internal routing protocol, that is OSPF, right? So what we can do, let us now advertise the next hop interface using the routing protocol OSPF. So I'm going to configure OSPF as a routing protocol and I'm going to advertise the prefix. So let us go here and let us advertise the prefix using OSPF. So regarding BGP, two things you have to remember. First thing, it will establish the neighbor using the TCP three-way handshake, right? So once the neighbor relationship is established, automatically it will share the updates, right? It will share the network prefix using BGP, right? So in this scenario, for sending the updates, I'm using the OSPF. So OSPF is for transporting the updates or for transporting the prefix between the routers. So I already transported the prefix, right? 12, 13 and 16. These are the next hop interface. So R1 it has 12, 13 and 16, right? So this next hop interface I advertise via internal routing protocol OSPF, right? So now let us go to R2 and let us advertise the internal routing protocol. So let us go to R2 and let us configure the internal routing protocol. So let us see the R2 interface. So R2 has three routes, right? One is 12.2, 24.2 and the loopback address 2.2. So these three connected prefixes I have advertised in R2, right? So R2 has 2.2, 12.2 and 24.0. So similarly, now let us go to R3 and let us advertise the routing protocol OSPF. So this is nothing but I am using OSPF only for advertising the prefixes. So in this scenario, for establishing the BGP neighbor relationship, I use protocol BGP, and for transporting the updates, I use the OSPF, right? So I'm going to advertise via OSPF now. So it is already done. And similar way, go to R4 and advertise the prefixes via routing protocol OSPF. So go to R4 and advertise via OSPF. So R4 has similar connector to prefixes, right? So R4 has how many prefixes? 24, 34 and 4.4. So that's the thing I advertise. Next hop interface 24, 34 and 35, right? So these are the prefixes in R4. Yeah. So now let us go to R5. So R5 has two interfaces, 5 and 35, right? Similarly, R6 has two routes, 6 and 192.16. So R6 has 16 and 6, right? So that is the thing I'm going to advertise. So R5 we already advertised, and let us go to R6 and advertise the routing protocol. That is 6 and 16, right? So I'm going to advertise. So now we are more or less done with the configuration. So let it take some time for coming the OSPF. So no OSPF came up. So now let us check the BGP neighbor relationship. Show IP BGP all summary. So we're able to see, right, previously it was showing in the active state because still I have not advertised the prefixes, right? So after advertising the prefixes via the internal routing protocol, I am seeing the prefixes. Now it is up, right? Neighbor relationship is established. So now let us go to R2 and check the neighbor relationship. Show IP BGP all summary. So now it is seeing the prefixes 1, 3 and 4. You are able to see the neighbor relationship. Similarly, go to R3 and check the show IP BGP all summary. So it is receiving all the prefixes, right? 1, 2, 4 and 5. So R3 has 1, 2, 4 and 5. R3 has 1, 2, 4 and 5, right? Similarly, let us go to R4 and check the BGP neighbor relation. Show IP BGP all summary. Similarly, it is established, right? Similarly, let us check for R5. So we're able to see the prefixes. Now let us see the routing interfaces, whether we can check it in the routing table, right? Show IP route. So show IP route shows all the interface, right? All the neighborly interfaces, and also it will show all the connected interfaces. So these all connected interfaces are advertised via the routing protocol OSPF, right? So it is showing 192.168.34, 35, and 16. Similarly, we can check in R6 also, show IP route. It will show all the connected interfaces, right? For R1, R2, R3, and R4 interface, everything it is showing. So now let us do one thing. I'm going to advertise some other prefix over here, and let us see the prefixes are getting advertised in all other routers. So that's the thing I shown here. So whenever R1 learns any information about the external routes, so as it is in full mesh with all other router, it will update all the router about this external route. So let us go to R6 and let us advertise a new prefix, right? Let us go to R6 and let us advertise a new prefix, interface loopback 3. Let us make it as IP address 8.8.8.8 and 255.255.255.255. So let us advertise this prefix via OSPF and let us see whether it is getting advertised to all other router. Okay, so go to configuration mode and router OSPF 100. Let us advertise the prefix 8.8.8.0 and 0.0.0.255 and area 0. So this is a new prefix I advertise in the external routes, and let us see whether all the internal routes are learning the information from the external routes, because it is each and everything is in full mesh neighbor relationship with all other router. So R1 is in full mesh with R2, R3 and R4, and R3 is in full mesh with R1, R2 and R3. Similar, each other router is in full mesh with all other router. So now let us see the route. Show IP OS route we can do, yeah. Show IP route OSPF. So it is receiving the prefix, right? It is receiving the prefix what we advertise in the external route. So that is full mesh is working properly. Similarly, go to R2 and check the IP route. Show IP route OSPF, right? So it is receiving the prefix 8.8. Similarly, go to R3 and check show IP route OSPF. So it is also receiving the prefix, right? 8.8.8. Similarly, show IP route OSPF. So that is the benefit of using full mesh IBGP neighbor relationship. Whenever it receives any information from the external route, it is the process of updating all the information because it is already in full mesh with all other routers. Same way, whenever R3 receives any external route from R5, so what happened? It will update all the information to all other router. So that is the benefit of full mesh for IBGP neighbor relationship, right? So it will always IBGP neighbor relationship are formed through neighbors, not between the neighbors, because whenever R1 will not whenever R1 sends an update, it thinks that already it is in full mesh with all other router, so it will not send any update to the directly connected neighbor because they already know each and every router is in full mesh with all other router. So that is the benefit of using full mesh IBGP neighbor relationship. I hope you understood. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.